So welcome to another one of the Antarctic Society speaker series. We've had the first one from Sarah Williamson, the CEO of Antarctic New Zealand, and all technology failed, so that was a bit of a challenge. We've had Michelle Finnemore from Comnet, who gave us a great presentation a couple of weeks ago. So this week we've got Simon Shilton, who's going to tell us about the Scott-based redevelopment. Now, Simon's a bit difficult to stalk because I didn't have a bio, and I tried some very quick hunting around online and couldn't find an awful lot. But I gather he's been with Antarctic New Zealand since 2011, so he's a long haul member of the organisation. But the Scott-based program, he's been pretty much from the outset, from the sort of business case days right through, and he's sort of one of the senior project manager for the Scott-based redevelopment. So he knows all about it. I'm looking forward to hearing him tell us the whole story. So Scott Shilton, Simon, sorry.
Thank you. Yeah, I'll communicate what I do know about the project, but the lovely thing about this project is it's so vast that no one knows everything, and we've got a really good team which I'll introduce that their energy and knowledge combined helps us achieve what's a really complex task. So thanks very much for coming along tonight. This image is a computer-generated image of the proposed Scott base, so hopefully in less than 10 years, this is what we'll be operating out of in Antarctica. So I do have a lower profile on the internet. I guess I like to be known as a quiet achiever, but it's a really popular project as well, so I can get harassed for products or jobs and that sort of thing. So yeah, I've worked for Antarctica New Zealand since 2011. I've had a couple of winters down there and a number of summers. I was involved with the last big project that we did at Scott Base, the Hillary Field Centre upgrade, which is in use at the moment. But I'm really fortunate to be surrounded by some exceptional talent, some of which is in the room or online, but we also have a team that works right across the world. So we sometimes can work 24 hours. Many of our consultants are based in the Northern Hemisphere, and that's where they have knowledge in the Arctic, where there is higher populations and people have been living in those cold regions for longer. But we've also got some really good staff that have a lot of experience on the continent. So the picture on the right is one of our assistant project managers. She's done over 4 traverses in the Antarctic. She's led Summit, she's been the station leader at Summit Station in Greenland. She's a very, very cool lady. The middle picture is a station called Halley 6, which is a British station, so Hugh Broughton architects were involved with that, who are also involved on this project. The team in the middle, so that was at one of the Marais, which is on Springfield Road here in Christchurch, where we took the team to stay a couple of nights over and to learn about what it means to live and to embrace the Kiwi culture. We're also really lucky to have Lee's Construction involved in the project. So whilst we did go through a competitive tender process that following the government procurement rules, Lee's were a strong contender in that, and it's for good reason. We've had a 20-year relationship with Lee's through Antarctica New Zealand, and they've been involved with all of our major upgrades at Scott Base for 20 years, so they're really proud to work with us as are we with Lee's. Just also like to thank all the staff members, scientists and the wider Antarctic community that have been involved with this project. We've had over 5 years of consultation and engagement to come up with the design and project planning that we have today, and that's some of those workshops and meetings are quite long. But that information has been really important to inform the design that we've got now. So thanks very much for those that have been involved. So just a quick outline of what I'll talk about tonight. Just cover off New Zealand's role in Antarctica, why we need a new base, the future base, what it looks like and some of its features, how we're going to build it, and how to get involved. So, New Zealand and Antarctica. It's the coldest, windiest, driest place on Earth, and I'm sure there's many hardened Antarcticans in the audience who understand that. It's got a mean wind speed of just over 19 kilometres an hour, with a maximum wind speed of around about 180 kilometres an hour. Its mean annual temperature is minus 19.8 or minus 20, and its mean temperature in February is minus 11, so it's consistently really cold. We have obviously 24-hour daylight in summer and 24-hour darkness in winter, and for someone that's experienced 24 hours in winter, it goes for 4 months, and that's pitch black. It's so dark you can't even see your hands in front of you, so it's a really unique experience. It's not always like this image though, and I think that is a common misconception, but you do get really severe and harsh conditions, which make it really interesting for us to work and operate down there. In saying that, we've done it for almost 65 years, so we know how to operate in Antarctica really well. So Scott Base is 3,800 kilometres south of Christchurch. Depending on what aircraft you take, it's around about 5.5 hours on the likes of the New Zealand Air Force Boeing 757, which was down there recently, or the US C-17 that arrived in Christchurch yesterday. So jets, around about 5.5 hours. Or if you're in the more traditional aircrafts, the C-130s or the Ski Ergs and LC-130s, it can be anywhere between 7 to 9 hours depending on the winds. To ship things down there, it takes about 10 days on a cargo vessel, and those vessels are always supported with an icebreaker from when they arrive at the edge of the ice to when they leave. So that's part of taking the vessel down there. You need close support for search and rescue, or, well, rescue for things like ships. But just for scale, the Ross Sea region in which we operate, and most of the time we do also work further afield and have had deep field camps outside of this region, but this is our primary area of operation. So around about the same distance, so that is to scale the map of New Zealand on the left hand side. So it gives you some scale up along the coastline there. And that red flag is Scott Base right in the middle, and then the largest ice shelf in the world is the Ross Ice Shelf, which is just south of that. There's also some other programs that operate out of Christchurch, those being the United States, which we collaborate really closely with, the Italian, Korean, and sometimes the Chinese and French program. So Christchurch is one of 5 gateway cities, so a really important strategic city for Antarctic operations. So our primary purpose in Antarctica is to develop, manage and execute New Zealand's activities, so that's around presence and science. So we look to maintain and enhance scientific research and collaborate with other programs to enhance scientific research. And everything we do, it really does come back to how we can better support science now and into the future. Our mandate is well, those three bullet points there. We operate under the Ministry of Foreign Affairs and Trade and are a Crown entity. So this is a real legend from Scott Base, and obviously involved with the initiation of Scott Base in 1956-57, Sir Ed Hillary, and he's played and had many visits to Scott Base during his life, and someone that we look fondly up to, and in fact we've got a meeting room named after him in our office. We've got a really rich history in Antarctica, and I'm sure there's many in the audience that know a lot more about that than me, but New Zealand, we really care about Antarctica a lot more than many other countries, and I think it's close to many hearts. So why do we need a new base? So whilst the current base is loved and has served us well for longer than we expected, it actually had a design life of 25 years, It is deteriorating and it is ageing infrastructure. There's also been technology advancements which have changed the way that we live, work and operate. And there's also changing expectations of users that they want, that they have different requirements and there's different cultures that go with that. The bar's no longer the most popular place on base, and things like spaces for relaxing and exercising and doing yoga or stretching are really popular. So it is, we've also got some key equipment which is old and it's getting more and more expensive to maintain, so we need to send people down, which takes up seats for scientists each year to maintain that and to keep it safe. And they're really important bits of equipment like the reverse osmosis plant, so we produce water to drink or for firefighting. It can also get overcrowded with sleeping arrangements, and at times when we've got peak populations on base we have to have sleeping containers, 20-foot containers that are fitted out with beds for overflow accommodation, which, yeah, all of this brings us to the point that it's time for a modern fit-for-purpose facility which supports our people in the way that it should now and into the future. So whilst the site looks reasonably straightforward, there's a very small amount, less than 2% of snow-free land in Antarctica, so it is quite hard to find a site to build on. And we believe that Sir Ed and Randall Hickey and Frank Ponder found a really good site in which we decided to stay at. So we have made a conscious decision to continue to build and maintain our presence in the same site. But it comes with some challenges, and it is actually what we call a really constrained site. So there's things like the sea ice, which you obviously can't build further out on. The further up the hill we talk about, you start getting into areas where there's long-term science monitoring. There's also areas of ecological significance in which we want to protect. It's got a road that leads sort of McMurdo to the South Pole, in which we are constrained by. There's also areas at the moment, at least through the construction period, that have things like external storage, or that strange word, wanigans, and storage containers. There's heritage infrastructure, so the TAE hut, which is still green in this image, which we need to work around. So it's not as simple as it looks. So the future of Scott Base. So just getting into the nuts and bolts of the project. We've got 5 strategic objectives for the project, and these are our guiding lights to deliver against what we said we would, which started in 2014 when reviewing our asset management plan. It led us to the outcome that it's time to replace Scott Base. So we went through what's called the Better Business Case process that Treasury run for all government investment. And in 2017 we were awarded our first tranche of money to proceed with designs of the new base. And at the end of this year we'll complete the design, so it may give you some insight as to the complexity of the design and the levels of engagement that we have had, and the staging of things like funding to achieve what we've done today. So these strategic objectives line up with with one of the earlier slides around maintaining a continuous presence in the Ross dependency. 2 of them relate to environmental stewardship, so that's something that as a small country we hold really dear to ourselves, and in fact we are an active member of things like the ATCM or the treaty meetings, but also our aim is to enable and enhance our support to high quality science. So our vision, to provide a safe, fit-for-purpose and sustainable research station that will support our presence in Antarctica for another 50 years. And it's a reasonably ambitious time frame to have a piece of infrastructure that lasts for 50 years. But we believe by setting that criteria, we'll have to go through this process less, but to also have a base that's highly resilient for things like natural disasters, like tsunamis or seismic events or volcanic eruptions, So we've done things like specify the design to what's called an importance level 4. So it's to do with a response to a natural disaster. So a hospital has a similar level of importance in terms of building resilience. So an image of the existing Scott base, and then the future Scott base. So for simplicity, the buildings are named A, B and C, stepping down the hill. Building A is accommodation and welfare. There's a lot of plant or areas where you have sort of behind closed doors that you're not quite sure what's there, but they make the building warm and also humidified in the case of ours, and it takes up about 30% of the building space within the new Scott base. Because many of our systems, you have to have backups for them as well, and also backups for the backups. So plant space takes up quite a lot of the new base, more so than existing. Building B, in the middle there, is for science, event staging, office space for management and also biosecurity. And building C is workshops, engineering, storage, gym, a cargo bay, and it's by no means proportional, so it's science in the middle. It's more so the hub of the new building with things like bedrooms up above and engineering support down below. Just in terms of floor area, so the current base is around about 6,000 square metres, depending plus or minus, depending on what you include, like storage. And the new base will be 8,597 square metres. And a lot of that is to do with having fit for purpose plant rooms and also access to services in case you need to. At the moment, they're under the floor, as you saw in the earlier image. So at a conceptual level, we've used the idea of interconnected floors so you can move between buildings and stay on the same level. And a lot of the drive behind that is because we move a lot of equipment around the base, we want to try and minimise the need to go up and down stairs or to use lifts. So particularly for areas like field staging, we literally use pallets and pallets of gear. So we've made floors that can handle pallet trolleys, but also floors that you don't need to go up and down lifts, so to try and increase the efficiency. And when we talk about science support, it's not just about really good labs, it's also about how can scientists move easier and more efficiently through the base. How can our base engineering team spend less time fixing things and more time supporting scientists getting out into the field. So these are some images inside the base, and they're just starting to come together as we, like I said, finalise the design, but get right into the detail of choosing things like fixtures, fittings, paint colours, and equipment. So there's open plan work areas, and these are there to encourage collaboration and cross-fertilisation between scientists to share information to improve scientific outcomes. We've got wellbeing and recreational spaces. These are there to foster a sense of connection, but also quiet spaces to recharge. It can be a really busy and active place down there, and sometimes people just need a quiet place to get away, read a book, or have a snooze on a Sunday afternoon. We've also been working really closely with some involved in developing a cultural strategy, but making sure that that reflects the vision and values of New Zealand. So that's around the science that we support and the science that we have supported, the resilience, Aotearoa, New Zealand's heritage, both in New Zealand and in Antarctica, of which I'm sure many in the audience are really proud of, as am I, and a group called Marapopuri who work closely with Ngāi Tahu to include cultural perspectives. So you'll see things like thresholds as you go through into the building. In fact, Marapopuri were involved with Turanga, the building we're in at the moment. We've also worked with a colour specialist, and some of my more hardened mates sort of roll their eyes and go, why would you need a colour psychologist? You know, what even is that? But it's actually really important in a place like Scott Base, where some people spend over 13 months non-stop. And some of those months, like I referred to earlier, are in the depths of winter where we know that people do suffer from seasonal affect disorder. So to see colours that change your mood or lighting that does, is proven through research to help your wellbeing, we want to embrace some of those ideas. So we've really looked right across the board to see how we can improve the station for the future. So moving into some more industrial spaces, the top right is what's currently known as the Hillary Field Centre, or an event prep area where scientists will gather their equipment. They'll go through things like biosecurity checks before they head out into the field, and then they'll deploy either through Hägglunds, helicopters, or fixed-wing aircrafts. Also use this area to come back into. One credential that the space can be used for is for large traverse events, so you can move all the cages, and it's literally just large open space for dealing with large deep field events, which we anticipate we'll see more and more in the future. Or you can segregate it so you have a number of smaller events. The improvements to these facilities to support science that we've really focused on is around wet and dry labs, the designed areas to test equipment outside and a roof deck for science. There's flexible caging to accommodate the different size events, and there's also specific biosecurity areas to minimise contamination from New Zealand to Scott Base, but also across the continent for things like scientists moving between penguin colonies. So designed to support wellbeing, and like I said earlier, it is really important that people can get a good night's rest, and for those who use the current Scott Base, sometimes you don't. And I can speak from experience that it can be quite tiring, especially if you're there for short periods. You're in a room with sort of 5 other people, and whilst people are respectful and they try to be, you're still sharing bunks with 5 people. So we've changed the configuration of accommodation in the new base. We do still have short, medium and long-term stays, but it's a mixture of 44 single rooms, so these are for long-term staff and scientists. There's 6 twin rooms, and these could be for mates who are working together, or for couples, because we recognise that does happen and it's normal. Or there's 10 quad rooms, so these are for short-term personnel who are only there for sort of 1 or 2 nights before they head back to New Zealand or out into the field. There's also 2 twin accessible rooms, so these are for people that need accessible access, but also they can be used for medical isolation, so their heating and ventilation system is negatively pressured, so we can control outbreaks. Powered by renewable energy. So the current wind farm needs to be, it completes its design life by 2030. It also doesn't meet the requirements or demands of the new station. And those demands aren't necessarily because the new base is larger. We're also looking, or have designed our new infrastructure to use more electricity than fossil fuel. So we've got, where we have backup plant for things like boilers, we do have A&8 boilers or diesel boilers, but our primary mode of use is by using electric boilers. So by doing so, that increases your energy load. And we think it would be quite counterproductive to have electric boilers and diesel generators that are powering them, so you need to have renewable energy that then powers those electric boilers. So our demand for renewable energy will increase, so the new wind farm will be larger. It will also have this thing called a BESS, or a battery energy storage system, or for simple people like me, a big battery that can store energy, and then we can use that when there is no wind. So sustainability in design and construction is becoming more and more popular, and we're really proud of that, and in fact have worked really closely with the New Zealand Green Building Council to develop a custom tool to evaluate stations in Antarctica. And this is part of our one of our strategic goals around leading environmental stewardship across the continent and role modelling good behaviours, and we're also really open to sharing the customised tool and also talking to other stations through how we used it and how it could help them drive their design and assessment, and also get credentials like 5 or 6 star ratings depending on what they aim for. There's a huge amount of station modernisation going on across the continent at the moment, and it's for a few reasons, but Michelle Rogan-Finnemore will be able to give you the exact statistics, but in a survey that they did, it was over 50% about 2 years ago that were either planning or underway with station modernisation programs. So it's a really good time to role model things like using the Green Building Council tools to assess design and building, so you have more environmentally sustainable buildings. So it'll be independently assessed at the completion of design, which will be in the next 6 to 9 months, and for us we're aiming for a 5-star rating, which is New Zealand Excellence. In fact, 6 is the highest, so we are aiming really high, and it's because we believe it's a really good thing. So how are we going to build this thing? Obviously it's not your average construction site, and we do have some really unique challenges, especially on a scale like we're proposing. It is huge. It's the largest project Antarctica New Zealand has ever undertaken, and for New Zealand it's the largest project in such an extreme and remote environment. So it's complex. It can be really inefficient. You have to build with bulky clothing, you have dexterity issues with gloves, you have goggles that fog up, you have to have balaclavas and that type of thing, so it can hinder productivity. Materials and equipment can be impacted by the cold, so that's anything from machinery through to sealants trying to set in -10 or -20, and weather can stop construction or delay aircrafts and ships carrying people and equipment. So it's a challenge that we ponder on a daily basis. And on the flip side, you also the sun's beaming down on you 24 hours a day in the middle of summer. So the UV and dehydration, both from needing to drink water, but also lots of hardy construction workers having to moisturise their hands. So again, it's not your average site, and this does happen around Scott Base, only at certain times of the year, and it's not common, but when it does, work stops and we wait for the wildlife to move on, and then we carry on. So you can't sort of send out a border collie to round them up and herd them off. You just have to go with it. So site preparation, this is actually an image from our civil design model, so hopefully it doesn't look too unfamiliar with sort of red dots on a grey scale, and it's done from a LiDAR survey. So these areas are where we'll carry out earthworks, and we look at things like cut and fill ratios, where you look to excavate from one area to fill it into the other to create level platforms. The work to prepare the site has already begun. In fact, we've got Matt Jordan in the audience, who has led our long-term science relocation projects, which was the first project to kick off, which started around 3 years ago, because we have overlaps in the data sets with some of those experiments in which we want to maintain the integrity. So we can't do any work until the data sets are sufficiently overlapped, and we have the sign-off from those scientists, and then we can start getting into earthworks where you start to move earth, which affects things like geomagnetic observations, or put large chunks of steel in the way, like bulldozers or steel structure. So all site works will be undertaken around the existing operational base, and this will include helicopter operations, sea ice traverses, the main road to the airfield, and wildlife, penguins and so on. So again, constraints that we need to work to within a daily basis. And just roughly speaking, the earthworks volume that we're looking at moving is around about 70,000 cubic metres. So for context, a concrete truck that you'll see driving around takes about 8 cubic metres, so it's quite significant. So Timaru Port, Prime Port, it's, so this is where the new Scott base will be built. We're looking to commence construction down there in 2023, and depending on what you define as construction, the team at the port are preparing that site and running things like services and fencing out there, and we're meeting with them on a regular basis, and I just can't tell you how excited they are, as are we, to work with the community down there. Prime Port's a deep sea port, and where our construction site is proposed is this area down here, which is currently the log yard. So we'll build the entire base in Timaru, and this helps to mitigate some of those risks that I was talking about earlier with things like cold and working with bulky gloves on and jackets. And Lee's Construction proposed this idea around construction based on their experience down in Antarctica, and after some work with some specialist companies, which I'll go into soon, we accepted the idea and went with it. We'll also test the equipment and systems. We'll do what's called commissioning down there, so we'll run the whole station up, make sure it works, and we'll also look to train our staff on how the new base will operate as far as possible. We also intend to have an open day once the base is complete to show the public what the new base will look like before it heads off or is broken into 8 modules, each of which are about 24 metres wide by 24 metres long and around 20 metres high, and they weigh between 1,000 to 1,500 tonne each, so there's 8 of those. The span, so actually looking, we'll roll the modules down a road here and then unload the onto the vessel, which will stick out into the port, into this area. And there'll be a span of around about 8 to 12 metres in which those 1,500 tonne modules will roll across this bridge and then be positioned on the back of this ship. This is a pretty special ship. It's called an MC class vessel, so a modular carrier class. All it does is carry modules around the world. There's 6 of these in the world. They're really special, and this one is ice strengthened, so it can travel in the conditions that you see it in. But again, it must be supported by an icebreaker as well, and you also need an icebreaker to cut the channel first to bring this vessel in. So we have engaged this company called Big Lift and have worked with them for the last 5 years. This is stuff that they do on a daily basis. It's really impressive, the work that they do, and they're the best in the world at it. So we're really fortunate to secure both this company and the vessel. It's in high demand, largely around renewable energy projects going on across the world. So sea ice conditions are really critical, and we won't know those until closer to the time. But these are some of the variables that can affect the success of the project. But again, they're not new to us. Doesn't mean they don't keep me up at night though. So it's designed for high seas, and this is where the complexity of the design comes into it. So we need to consider things like wave heights and weather parameters. And the building's going from a maritime climate, and let's say it's a warm nor'wester on December the 25th, 2026, and then it heads down to Scott Base, in which it's could be around -20 in March or even colder. And the building actually shrinks as it gets colder, and it's a lot drier. So we have to allow for that shrinkage and consider it when we have things like the connections to our piles. So we need to allow the building to be able to slide before it's fixed together up to 50 millimetres, which across the building is quite significant. So we also need to, because we're commissioning and building this as much as possible, we also need to test how the interiors will survive. So if you can imagine a room like this going on the back of a ship, being lifted by these really special things, which I'll show you shortly, and then being shaken around at sort of 1 to 2 G-forces in the sudden motion. It can move things like projectors and ceiling grids and floors, so we need to know exactly how much it may move them, and that'll determine how much we do in Timaru or how much we do at Scott Base. It's never a dull moment in our office. So these are the things that will lift them. They're called self-propelled modular transporters. It's with a company called Mammoet. They work really closely with Big Lift. And if you're bored and want to jump on YouTube, just have a look at what some of these things do. They're really impressive. They can lift really large loads. They're extremely precise. Millimetre accuracy on gravel, all-terrain sort of ground, and they're really impressive. They move at walking pace, so you can literally walk alongside them with kind of an iPad and direct if it goes left or right, and the whole thing can move 360 degrees on the spot. But these, it's really specialist stuff, but you'd be surprised how high their demand is across the world. And the precision, both loading them onto the vessel, but also into position. If you can imagine, we have to get the modules within millimetres of each other. These are really impressive pieces of equipment. So building the new base, some may have seen this, these cartoons online. They're actually a really good way just to communicate the process. Just moving from slide 1, so I've talked about the construction in Timaru and the temporary work that will be required, and the construction in a reasonably typical way that you would in New Zealand. The slides in orange are all work in New Zealand. Meanwhile, while the base has been built in Timaru, we're actually commencing that this year. There'll be site work going on in Antarctica, so we need to prepare the site in Antarctica to receive the modules at the same time as we're building the buildings in Timaru. It's quite a strange project where you have what's called 2 critical paths, and sometimes it's doing things like earthworks, nothing to even do with building the building, which is the thing that could slow you down the most. So we need to make sure that both sites are working in tandem and that the modules are ready to leave when the site is ready to accept them. So once the modules are put on the vessel in Timaru, which is slide number 7, they head down south, and then the modular carrier reverses in at Pram Point. So we need to construct a temporary wharf on the current site, and that's where the span of 10 metres again comes into play. When you have a large bridge that spans the land to the ship, and we have to deal with things like the tide during this offload. It can take up to 1 day to move one module. So you've got a whole lot of complexities to think about. There's also risks of things like the sea ice breaking out, weather coming in. So it's going to be a really interesting time, and everyone I talk to wants to be down at Scott Base when that's happening. So it will be fascinating to see. Modules are then positioned, as in slide 10, and then connected together, and then there's a really important joint between the modules, which we call the stitch joint, which will need to be done on site, obviously. We've then got a team that will stay there through March, April, May, and some over winter that will do what we call the final commissioning, make sure the systems work, make sure it's warm enough, make sure we've got water, power, the freezers are working for food, and we'll also have the existing base running at the same time, so we'll have 2 bases just in case something goes wrong. We really want to stress test the new base through an Antarctic winter to make sure that it's safe and ready to be used. So protecting the environment, we do take this really seriously, and New Zealand does have a good reputation for environmental stewardship, and it goes right back to championing things like environmental assessments in the early 90s, which we then role modelled out across the Antarctic Treaty and other Antarctic programs. So we want to maintain our reputation there, minimise our impact, and we do set ourselves some lofty goals, but also make sure that we do comply with those protocols, biosecurity rules, We look to minimise and manage our waste as much as possible, and that's one reason that building this in Timaru it really does help with that. And then we've had a monitoring program in place for the last 3 years, and will do right through the construction period and post, to really understand the impact that this construction project will have on the Antarctic environment. We've also got control stations which are away from Scott Base to check that information against. And a lot of this approach is outlined in a publicly available document which is called the Comprehensive Environmental Evaluation, a CEE, a great read if you ever bored, so 300 or 400 pages of, but it does set out the project in great detail and is approved by our Minister, Nanaia Mosier. So what's happening this summer? We're in the throes of buying a bunch of things. Some of that is plant and equipment, which will go down on the vessel in January, February this year. We also have a whole lot of building materials and construction work which the team are working on at the moment, which will also go on the ship to be carried out in February, March, but also through winter, which we'll have a team that will work through the winter to convert the existing base to increase the capacity from 86 to around about 160. So we need to increase the population of the existing base so we can continue to support science in the way that we currently do. We don't want to impact the science program by building a new base, so we need to have more beds for construction workers crudely. So that's why the base will grow severely for about the next 4 to 5 years and then be deconstructed and brought back. So we're thinking ahead. The other major piece of work this year is preparing the site, so a lot of earthworks. We also need to clear the site, so getting rid of some of the containers that we're using for storage, and basically having a good old clean out of the site. And then we'll start getting into the construction and earthworks proper next season. We're also finishing off long-term science and the commissioning of those buildings and getting the final experiments in there, and carrying out things like geotechnical investigations. So that's where we look at the ground profile to understand the timing of the earthworks and the type of material that we'll get out. And then starting to, like I said, carry out those refurbishments of the existing base. The team that are working on the base will start to incrementally increase. We've got around about 70 people that are just focused on the base of the Scott Base redevelopment project this year that are going down. Most of them are trades or plant operators or consultants to measure, assess, inspect and sign off on things. So project completion in 2028, everyone likes to know when it's going to be done by, and rightly so. But look, this hasn't changed for us since 2017 when we, I would like to say that we were realistic in some of our estimates. In fact, we're planning on finishing it earlier, but in saying that, I wouldn't want to build a rod for my own back, because I've just shown you some of the complexities that we've got to try and navigate as well. But this is our target completion date, and that's when we expect to have science operating out of the new base, when we have scientists and operational staff sleeping in those bedrooms in which I showed you. And in that final year, we'll be looking to do these activities, so commission through winter and test any residual services that we needed to. And then we need to deconstruct the existing base, so there's quite a large piece of work to remove the current base, every last piece, which will come back to New Zealand, and as part of our Green Star assessment, we'll recycle as much of that as possible, and then dispose of it in the most environmentally responsible way possible, and then we'll do what's called landscaping, or tidying up the site so it can be so it's being operational. Things like helicopter pads or access ways around the new base. So ways to get involved, or how to stay in touch. We do keep our website up to date. So if you are interested in any media releases or any of the latest news, just please visit our site, just Google Scott Base Redevelopment, or there's also some information which is linked to that on the Antarctica New Zealand website. You can sign up for the newsletter on that website, and that's where we do send out regular updates. We've got a physical model in display in this building at the moment. It's over in the way I'm looking in the far left-hand corner. It's a really realistic view, and between the CGI images and some of the stuff I've shown you tonight, I encourage you to have a look at that on your way out. And next to that, there's this really cool thing. If you have a smartphone, you can scan the QR code, and it's almost like, if you sort of put your phone up to your face and didn't look at it too close and get square-eyed, but it's like a VR image, and you can actually look through some of the spaces in 360. So, really good to have a detailed look inside. Or you can also consider joining Antarctica New Zealand or joining the project team. We do advertise for Antarctica New Zealand and Scott-based roles at the beginning of every year. That's for both summer and winter. All about procurement. Being a government agency, we put that through GETS, or the Government Electronic Tendering System. And then Lees will lead the recruitment process for the work in Timaru and the associated supplies with those in 2023, so keep an eye out for that. And lastly, as I said before, we are planning a walkthrough of the new base in Timaru in 2026-27, so put that in the calendar. Thanks for listening.
Well, thank you, Simon. It's a really impressive project. It made it even more impressive by the timeline, because it's only 6 years away, and I've worked on some IT projects which have taken 2 years, and that's sitting in a nice warm desk and in an office somewhere. So there's a mighty amount of work still to be done. You happy to take some questions?
Yeah, that's fine.
Cool. Any questions?
So the long-term science projects, are those seismic and magnetic field, are they?
They're wide and varied. In fact, the person just behind you, Matt Jordan, knows them very well. And I'll cover the ones that I know. Matt, feel free to join. So we've had to, for NIWA, we put in a new anemometer, a new weather station, where there's also temperature thermistors for ground temperature, which is to do with Waikato. We've also replaced the geomagnetic huts. So it was actually this really good story here where current observations at Scott Base are pretty good, and I think the scientists will say that they're okay, but the location that we've put them, which is up at Arrival Heights, is less disturbed, and we're getting higher quality data out of that. We have also relocated an experiment called Chloe, which is it measures chlorine in the atmosphere. What else have we done, Lee?
So we spoke about the soil climate station, which is an Manaka link there. Experiment working in collaboration with Waikato. We've got Chloe that I spoke about, the anemometer, and there's also a Stevenson screen there, so a weather station that measures temperature, humidity, and a number of other things. Those are the big ones, I think. The large ones. There's a seismic bunker down at Scott Base, which is remaining where it is. And there's a NZAS antenna that's run by winds, which is also staying where it is. So those two experiments are far enough outside the building footprint that they won't be affected.
I guess our premise was, if it's not going to be affected, don't move it, because that's the best outcome for all. So things like the seismic bunker was a good example of that. But then, where some did need to be moved, we looked at what's the best location for them long term. And so that's why some have gone up to locations like Arrival Heights. It's also given, we wanted to future-proof and have some areas for perhaps future experiments and installations that wanted to be put in those places. So we have considered where the new base will go and allowing space for future long-term science monitoring as well.
Something here they really do like this waste, the waste oil and grease, and they, have a, stop that into the environment, but, that's the short way to, so, yeah, back to Jim.
Yeah, so the question was how do we deal with waste oils and cleaning up, say, servicing of bulldozers, for example. So we ship everything back to New Zealand. So when the mechanics do an oil change on a bulldozer in the vehicle workshop, they capture all of that oil, they put it into the relevant drum, and then that's shipped back to New Zealand on an annual basis. For our human waste, we have a wastewater treatment plant in the current base and in the new base, and we try to minimise or process as much of that on site as possible. In fact, one of the enhancements in the new building will mean that we can deal with food waste as well. At the moment, we just, if you have any food waste, so we encourage everyone to clear the plate, you put it into a sack and it gets shipped back raw to New Zealand. So with the new base, we'll be able to treat some of that on site, and we'll only have a really small residual byproduct that we ship back and could be used for fertiliser or it's incinerated.
How do you manage the risk in relation to building and construction materials going up and down in price?
Yeah, yeah, it's a really good question. I mean, we're building in New Zealand. We're in the same environment as every other supplier and contractor at the moment. It can work against us being a long duration project, or it can work for us. So, I mean, things like inflation are challenges at the moment. The US dollar dropped significantly last week. So yeah, we're just trying to navigate those challenges at the moment, but yeah, we're not immune. We just add to the complexity.
So the buildings are built a bit smaller, or?
Yeah, it's not that simple.
No.
And so every time we propose something like, why don't we make these buildings smaller to save some money, what it means is rather than 100 beds for scientists, you have to cut it down to 90. So you cut capability. It won't make any difference on that big ship and the icebreaker and the people that we send down to commission. So we have all of these base costs that if you reduce capability, you're still going to have to pay the same amount. So it's really hard to do at this stage of the design and planning, especially what's called phasing and scaling in business case language. So to phase it would mean you just send one building down on 3 different ships. That's going to cost a lot more. To scale it up or down, you still need that base cost to do earthworks, to do piling, to have a temporary base, to have a vessel, to ship it down, to have an icebreaker, that sort of thing. So it's a really unique project. And we have been through 2 really rigorous, they're called value engineering, where you assess the whole design to look at where we can optimise it to save money. We meet with users, with suppliers, with design consultants to say, is this really the most efficient way that we can do it? And we believe we've got to a point where if you do that any longer, you'll start to compromise your capability over 50 years, and you'll end up with something that you're going to have to fix in the short, in the not too distant future. So, not smart approaches.
So the whole thing seems optimal. 2 questions. What's the estimated cost? And you talked about the earthwork. And have we had on Antarctica earthwork that deep? And if we haven't, are we expecting to discover something there under the soil, under the ice? Gold.
What was the first question?
Price.
Price. So we're funded for $344 million. So that was awarded to us in budget 21, and that's what we're currently working to. Now, are we going to discover gold? So the question was, have the scale of earthworks been done before, and are we expecting to find anything? So we know that we've been on that site for the last 65 years, and personally I've dug up treasure from there, which has surprised me when we've done other projects. So we know that there are some stuff from the first base when it was removed that may be there. And there's also small amounts of asbestos in certain areas which we know. It's documented, it's well recorded, and we're planning to deal with that as well. And the way that we're planning on dealing with it is to leave those areas of known hazards like asbestos, not disturb them. So one way to deal with asbestos is you can do what's called capping it. So we need to build the site up. So we will cap those sites by putting fill in them. So that's to try and minimise that risk, but it also ties into the design. We need to have the site levels at those heights anyway. Has that scale of earthworks been done before? No, it is really significant. And there's a couple of reasons why we can do larger earthworks than we have in the past. So one, technology. Earthworks equipment is far more advanced than it was sort of 40 or 50 years ago. But it also means that it will reduce our operating costs over the long run. So it helps to reduce things like snow drifting. If you've got a site that can house the buildings, and if you saw they were on piles or stilts, so that's to deal with snow blowing underneath them to stop snow drifting in certain areas. And then when it drifts in certain areas, we have to have loaders and excavators every summer for about a month, digging that snow out and depositing it somewhere else. So we'd rather try and fix it with a longer term solution, like earthworks and shaping the ground. And it also helps to have safe circulation and deconflict things like heavy plant machinery, big bulldozers, and then people walking around. You know, that's quite a dangerous combination, so we want to have a site that circulates and functions as safe as possible as well.
Definitely like that, Simon. I've got two questions. You touched on health and colour and light. So my first question is around empathetic lighting and circadian rhythms, and obviously the daylight you need in the winter for the winter over team. But with the summer team and the knowledge that's coming through around blue light and circadian rhythms and sleep patterns in the summer, is that all being built into your thinking? And my second question is, I just see that big ship with all your building on it. Did you look at having two ships? So that you don't lose it in the work? Is that your most vulnerable moment in the whole process? Is actually getting it down there from when it leaves New Zealand to when it arrives?
And possibly the most expensive part as well.
Yes, I know,
Yeah.
but I just...
You guys must have been in our office. So the first question was, how have we considered light, as in light systems within the building for summer and winter, for health effects. So one of our design consultants that were on the first slide within our team, they design our building services, and they're called Stenson Farming. They are involved with the Opera Theatre in Sydney, and they are passionate about lighting and really good at it. Obviously the Opera House is an external example of that, but they also do consider lighting within the buildings. And I'm no expert on the types of light, but it has been considered in things like the bedrooms. And for summer, one consideration is trying to block the sunlight out so you can have a dark room. Yes is the short answer. Technical details, not sure. The second question was, what about having two MC class vessels, the ones that carry the modules? So yeah, it's an interesting question in risk management and cost. So two vessels does cost more, and in fact we did initially have two vessels. In one of our value engineering exercises, we reduced the size of the base down so it fitted on one vessel. I guess there's two schools of thought on the risk around that. You can either spread your risk and have two vessels, then you only have half a base, or you can have one vessel and be very calculated and manage your risk very closely. So that's what we've opted for. And it's a really complex piece of design and planning work, which particularly our structural engineers have been really involved with, and the structure is very rigid to deal with both the loads in the shipping case, the moving of the modules. But yeah, that was a big driver to go with one vessel, and it's got the boat has this thing on it called the octopus, and so it's sort of a hub of information that it gathers from a whole lot of different sources, and so it gets things like hindcasting, so you can look at forecast over the last 60 years through that voyage. We also get information from all of the vessels that have carried out that voyage, so they build this model that informs that route. And then you get weather forecasting from a whole lot of different sources while you're on that voyage. So that can tell the boat to slow down, speed up, go left, go right. And you also have sensors on the building modules themselves, which go back to this octopus brain, which tells the captain to behave in the way that they do. So they might stop in some areas to avoid storms, they may go faster. But for Big Lift, this isn't their first time going to Scott Base. In fact, they're working in the Rossi region this year and have done a lot with the likes of the Italian program. So another one of our controls is to work with experienced operators. So yeah, we can't afford a second vessel even if we wanted it.
I think one more question, and then...
I'd like to reinforce the lighting question and to ensure that your design people are given instructions that the LEDs are no more than 3,000 kelvins and preferably only 2,200 kelvins in order to avoid having them on sleeping pills down there.
Good, I'll happily pass that on.
Not so much a question, but some good advice. Thank you. Well, I think the plan is to head to the old government buildings if you want to continue the conversation, so we would welcome you to join us over there. But in the meantime, thank you very much to Simon.